Alright, now let's simulate this design here for behavioral. So we first to put this as our top level entry, and then we need to design a Testbench file for this one. So first we need to create a new file again for Testbench file. But now we're gonna use, because the add sub and this one, the functionality are almost the same, so we're gonna use most of the code from the Testbench file for add sub. So let's open that one first of all, nbit add sub, nbit sub Testbench, and then let's use this file here. Most of it, just copy it and let's paste it here. First of all, we need to save as we need to save it our file as Testbench nbit behavioral. Save it, and then we need to change the module name, must be the same, so Testbench nbit behavioral, and then we need the module name that we're gonna put it here. So it is not nbit add sub again, so it is nbit, this one nbit, so the module name, this one nbit, so we can just copy it, nbit add sub. So make sure that it's the file that we want to check it, nbit behavioral add sub, yes. So we have control, we have x, y, sum, carry out, but we don't have the overflow, so we need to take it out here. And then we can take it out here too, so we don't need it. Overflow. Yeah, so that was our behavioral test bench. Sometimes you need to just reuse the code. And let's save it and then analyze and synthesize. So let's see if we have done everything correctly. Yeah, so no errors. Now let's just try and simulate this module. So, and then we must make sure that this is our top level file. It is nbit behavioral, and try to simulate it. So we can go to simulation, open the ModelSim. So we should expect the same answers. And then we need to go to compile, behavioral and nbit behavioral. So these two files here, compile, no errors. So we go to work and then simulate the test bench. So we can add all the value to the, and then toggle the name leaf. But we're gonna use TimeScript anyway. So let's just simulate to nanosecond and simulate all. Run all. So as we can see here, this is our simulation for all combinations for minus and plus. So for the plus operation, we can see it is work perfectly. For example, we see 15 plus 0 is just 15. If it is unsigned number, this is a signed number, so it is minus 1 plus 0 is minus 1. So we can see basically there's no errors here, but you need to check for overflow bit. But the overflow bit I've shown you how to implement on the structural design. They are similar. So let's go back here. One thing I want to show you here is we look at last time at our net list for RTL view. Let's look it again here now here too to see how the compiler did it for behavioral. So we can see here the compiler did his own job to basic. One of them is add, one of them is subtraction. So we can see we have our control here, and then this is our multiplexers 2 by 1. So here we can see we have sum out. So the control here, if it is 1 or 0, let's come here to check and let's take the answer from here. Oh, here. So if it's 0, it's 1, it's all take from here. And then this is for the carry out. So it take all the last bits for the carry out. So you see, you cannot go on the next level. It's just one layout. The compiler take care of everything. So this is for this video, and then on the next video we're gonna talk about how to combine the behavior and structural and how we can use the hexadecimal to display the numbers.